Ladies and gentlemen, welcome. This is the lesson 5 through 8 review for Unit 8.1 Contact Forces. At this point, we had been investigating collisions for quite a while, but we started to ask the question, how do the forces compare on the objects during a collision? So we started using these spring scales to measure the forces. Remember, we collided them into each other in different ways. We took this one and pushed it into the other one. We took this one and pushed it into the first one. We pushed them into each other. We even pulled like the one to the other to the one, or both of them at the same time. And what we found over and over was that the forces between them were the same. So when I took this and pressed with a force of 2 newtons onto this one, there's 2 newtons on both of them. So that means they're both pushing on each other with a force of 2 newtons. The same thing happened when I pulled. Like if I pull this one into the other one with a force of 3 newtons, there's 3 newtons of force on both of them. So they're both pulling each other or pushing each other with the same amount of force. It didn't even matter if we used a larger spring scale. Like this one measures 10 newtons, so it's almost like a stronger spring scale. And even when I pushed a stronger spring scale into a weaker one, the green one gets pushed in further than the tan one, but when I look, they're both at 4 newtons. So even though the green one's getting pushed in further, it's the same amount of force on both. So even when I take a stronger spring scale and push it into the weaker one, they still end up putting the same force on each other. But this was just kind of pulling and pushing spring scales together, so we tested this out with collisions. Remember, we attached them to our carts. We ran our carts into each other. Sometimes the cart on the left was moving into the one on the right. Sometimes the one on the right was moving to the one on the left. Sometimes they were both moving together. And even there, the amount of force that they put on each other was the same. We could never get a situation where one cart was putting more force on the other cart. Here I have the same thing set up, just with fancier equipment. So I have 2 carts here, a gray cart and a blue cart. I have on top, not a spring scale like you guys had, but it's a sensor that measures force the same kind of way. There's a little thing on the end that gets pushed in, just like your spring scale gets pushed in. It just measures it electronically instead of using a spring. What I'm going to do is the same thing you did in the investigation. I'm going to run these carts into each other, and on the left-hand side on the graph, it's going to record the force on each of the carts. So let's see what happens when I move the gray cart into the blue cart. Do you see it registered or recorded the amount of force? And do you see the amount of force is the same? We have about 7 newtons of force on the blue cart and about 7 newtons of force on the gray cart. Even though the gray one was running into the blue one, they both put a force on each other, and it was the same amount of force. Here I have the blue cart hitting the gray cart. We'll see what happens there. And you see the force isn't the same as the first collision, but in this collision, they still put the same amount of force on each other. So even though the blue cart was running into or hitting the gray one, they both on the sensor read the same amount of force, about 8 newtons of force on the blue cart and about 8 newtons on the gray cart. So when they collide, the carts are putting a force on each other. The blue one is pushing the gray one with a force of 8 newtons, and the gray one is pushing back on the blue one with a force of 8 newtons. So they're pushing each other. Here's video of both of the carts moving into each other. So they're both moving when they collide. And the same thing happens again. It's, again, a different amount of force in this collision, probably because they were both moving this time. But they both put the same amount of force on each other again. So I don't know, it's a little over 15, maybe 17 newtons on the blue cart and 17 newtons on the gray cart. Okay, so both carts are putting a force on each other, and it's the same amount of force. And the other thing you notice is it's in opposite directions. Do you see how one line goes up and one line goes down? So that's showing that the forces are in opposite directions when they collide. Like in this case, the gray cart is putting a force on the blue cart to the right, and the blue cart is putting a force on the gray cart to the left. So during the collision, they put a force on each other. It's an equal amount of force, and it's in an opposite direction. Sometimes we make what are called free body diagrams to better show the forces acting on an object. I'm not real good at drawing, so I usually just literally use a box. So I'm going to make one box to show the forces acting on the gray cart, and then in a different location, I'm going to make another box to represent the forces acting on the blue cart. Next, I'll label those boxes blue cart and gray cart. Okay, and then we have used arrows to show the forces acting on the objects. So we said the gray cart was pushing the blue cart to the right. So we would show, is there a way I can make my arrow go the other way? Oh, there we go. So we would show an arrow going to the right. It's hitting the blue cart, pushing it to the right. And then we said the blue cart was pushing the gray cart to the left. So then we would have an arrow going the opposite direction. But it would be the same size arrow because they're the same amount of force. If I wanted to, I could add numbers to this too, and it would be, what did we say, about 17 newtons of force here and 17 newtons of force here. So this would be a free body diagram, it's called, showing the forces acting on the blue cart, and then another free body diagram showing the forces acting on the gray cart. And again, in your free body diagram, you're showing just the one object you're focused on, only one object, and you're going to show all the forces acting on that one object. You don't necessarily need to know this at this point, but there's a name for this idea or law really, because this happens all the time, that whenever two objects are in contact with another, they put equal and opposite forces on each other. It's called Newton's third law of motion. That says for every action there is an equal and opposite reaction. So when the gray cart puts a force on the blue cart puts an equal and opposite force back on the gray one. Or when the cannon puts a force on the cannonball, the ball puts an equal and opposite force back on the cannon. So for every force or action, there's an equal and opposite force back on the first object. So basically, you can never have just one force acting at a time. Forces will always act in pairs.